So the first question on list for today is, what exactly is a OneBox? And here we need to understand that a OneBox, it is typically a high emission standard silencer, such as EPA 10 or 17, equipped with a full range of after treatment components. And these are the difficult three-letter combinations that we know as the DOC and DPF, SCR, as well as ASC. And what's so special about exactly the OneBox configuration is that all of these components, the DOCs and the DPFs and all the others, they are arranged internally in a box configuration. And so therefore, the term OneBox refers to all of these emission components being found in a one box rather than an elongated array of separate modules. And if that is clear, then here in the next slide, we can see exactly the elongated array of separate components, right? So this is not a one box. It is a elongated example of a high emission standard ATS system. But it does a very good job at illustrating what kind of components are generally found inside these systems. And if we were to simplify this, you can look at these systems in such a way as to recognize two different parts. So the first part is the DPF system, which is located here on the left side, so closer to the system inlet. And then the second main part of the system is the SCR system, and that is located to the right or closer to the outlet. And the main task for the DPF system is to remove the contaminant that we know as soot. We see that as the black smoke that's coming off the tailpipe. And the main task of the SCR system is to remove the invisible contaminant that we know as nitric oxides. And so both of them are poisons, both are recognized by the Health Commission, and both are regulated by whoever is issuing the emission standards. And also why I wanted to show you this general layout of the system, we need to understand that this is not exactly the US OneBox that we are looking at here. It is an alternative that basically consists of all the same components. And in order to run the DPF and the SCR system, we now need a whole array of different sensors, actuators, pumps, control units, and whatever we have here, right? So this is no longer just a metal piece. This is right now a computer-controlled, very complex and highly calibrated system that depends on a lot of inputs from different sensors, depends on a lot of different pressures and other signals, right? So this is right now a very, very complicated piece of technology that we are looking at here. But here we can see the first part of the system, which is, as we know, the DPF system. And if we are looking at the hardware, then generally it consists of two main components. So the first one is a DOC. Well, that is a simple oxidation catalyst. The job of this catalyst is to burn any escaped fuel and oil particles. And then once those have been successfully burned, we are looking at a DPF, which is essentially a mechanical filter. So the main purpose for the DPF, if not the only purpose, is to store the black soot or smoke particles. And it is achieved by actually a very specific cell configuration, right? So at the very core, we have a ceramic substrate body. And this ceramic actually has porous walls, which means that the gas is able to pass through these walls. But by blocking the channels in an alternating fashion, for example, on the inlet side, one channel is open. On the outlet side, we can see the same channel is closed. By doing this, we are essentially forcing the gas to pass through the porous substrate wall, and therefore the black smoke particles or soot particles are trapped within these pores. And so the end result that we get a filtered gas that no longer has any soot particles found inside it. Well, then what I can also say about the DOC is that it also plays an essential role in regenerating the DPF. So the regeneration is a process where we are burning everything that we have collected inside the substrate. We are burning that to crisp and essentially cleaning the DPF so that it can start to store the soot particles once again. And in order to regenerate, we need to elevate the temperatures in the system quite a bit. And so in this process, we are injecting extra diesel fuel into the exhaust system. This diesel fuel is then spontaneously combusting inside the DOC because the exhaust gas is full of oxygen. And by combusting it inside the DOC, we are essentially burning the DPF clean. So that's as much as we need to remember about the DPF system. Then we can take a look at the SCR system. And the main purpose for the SCR system, or actually the only purpose of the SCR system, is to reduce nitric oxide emissions. And nitric oxides are actually quite an important, quite a dangerous substance. They are known to create various health diseases, including heart diseases among those. And so it is recognized as a very serious contaminant that should be paid special attention to in these emission standards. And therefore, nitric oxides are one of the main attack points for these high standard emission systems. And the SCR system contains, at its very center, it has the SCR catalyst. So this catalyst is actually doing the job of reducing the NOx into free nitrogen and water, but it needs one key component in order to do its job successfully, and that is it needs the addition of DEF to the exhaust gas. So DEF stands for diesel exhaust fluid. It is a special mix that contains water and ammonia, or sorry, not ammonia, but urea. And so when we inject DEF into the exhaust stream, we are essentially providing the extra missing ingredient for the exhaust stream that the SCR needs in order to be able to reduce nitric oxides to free nitrogen and water, right? So that we can see here. We will usually have a DEF pump that will build pressure. We will then have a dedicated DEF injector that will be injecting under high pressure DEF into the exhaust stream. There, we will need to mix it with the exhaust stream efficiently. Otherwise, if we are just leaking it inside, then it's not going to work. And once it's been mixed, it enters the SCR, and there we have nitrogen oxide or nitric oxide contaminant together with ammonia, NH3. Well, this ammonia is formed during mixing. When the DEF is mixing with exhaust gas, it transforms from urea into ammonia. And then both of these poisons enter the SCR cat, and there they are reduced in free nitrogen, so completely neutral substance, and water, as we know, also a neutral substance, right? But as we know, no process in life is 100% efficient. The same is true with SCR reaction. And some of that ammonia will be trying to escape the SCR catalyst, some of it that hasn't reacted internally. And for that, we are adding a separate stripe at the end of the SCR substrate that we call the ASC coating. And this ASC stands for anti-slip or ammonia slip coating or catalyst, right? And yeah, so the main purpose for this ASC coating is to reduce any excess ammonia that is trying to escape our SCR system and poison the atmosphere. Okay, that's as much as we need to know about how the emission systems actually work. And then we can spend a little bit of attention to our own US OneBox product that we are so proud of. And I would like to tell you a little bit more about the development of this product. So we know that it's been one of the key milestones that we have had to overcome. It was also at the time our largest and most important product that we had developed. And so therefore it took considerable amount of effort. And in the development process, we actually did a number of activities that helped us reach the optimum result before manufacturing an expensive prototype. And these activities are computer simulations. And we have conducted those for 3 different purposes. So frequency analysis to see if there are any fatigue cracks likely to form in the construction. Thermal analysis to see if there are any hotspots that could likely cause trouble. And flow analysis to arrive at the optimum flow conditions inside the geometry of the construction. And then once the simulations are pointing us in the right direction for the design freeze, which essentially means that now we have found the design that works the best, then we are proceeding with producing the expensive prototype. And then the prototype is, of course, tested. And the tests that we have done with the physical product include NOx conversion efficiency tests, soot filtration efficiency tests, also noise reduction, because we know that noise reduction is a very important function of any silencer. It's actually the name silencer itself implies it, right? Then we proceeded with hot shake tests. And in the end, when all of the results achieved were sufficient, then we proceeded with the actual field test by mounting it on a truck and letting it dry for a period of time to see if any weak spots will reveal themselves. And then what we have in the end is a finished product, which contains also patented solutions. It has been derived by finite element analysis in the computer, supported by real-life tests in the test center, and in the end supported by an actual field test. And so we were ready to deliver it in the market, and we are still doing so. And now I would also like to briefly mention some of the key differences that we have found that we have implemented on our design as opposed to the original. And the first key difference is that we have improved the fatigue resistance of the hanger brackets on our design, because we know that on the OE design it was a problem. Every now and then we could see fatigue cracks forming in the place where these hanger brackets meet the body of the silencer. And therefore, after a while, these cracks become larger and larger until the construction eventually fails and it needs to be welded. But as you weld it, you're essentially only postponing the same thing to happen again, because you're introducing another stress in the system. And so therefore, our construction has a different geometry on the hanger brackets that is aimed to distribute the stress a little bit more evenly and prevent the fatigue cracks from forming. Then the second difference that we have included in our design is a different design of the mixing chamber. And as we understood from the previous slide, mixing is a very important process inside the silencer. We need the mixing to occur between the exhaust gas and the injected DEF. So this is the purpose of the mixer. And whereas on the original design, the mixing was formed by simply an open cavity, well, this is not ideal. It has led to some failures that we will also see in the following slide. In order to improve the situation, we have incorporated our patented design, which is a U-shaped mixer. And this mixer actually does a much better job of maintaining the mixture without letting it crystallize on the walls of the flow passage. Right, so essentially what we have is a more efficient mix. We have a longer lasting system because crystallization is not that fast to occur. And we also have less AdBlue consumption, which means we can save some money on the, not the AdBlue, sorry, this is what we call it in Europe. We can save some money on the DEF because we have less DEF consumption. And overall, we have a better NOx conversion, which means that we are actually running a cleaner system. And then the final thing that we have improved on our design is that we have added the DEF awning kit that we know came as a solution against high duty cycle DEF crystallization on higher power applications. Well, whereas the original design had this issue and they needed to introduce the DEF awning as a corrective action, well, then we have equipped all of our OneBoxes from the factory with the same exact DEF awning kit. right? So no need to purchase it separately and do a comprehensive installation procedure. We already have it supplied and installed in the system. And yeah, the main job of the DEF awning kit is to actually prevent the crystallization of DEF, which is further prevented by our U-shaped mixing chamber. So this means that our design of the OneBox is built to last longer. But that is it from my side. Perhaps you will have some questions for my presentation, and then after answering those, we can give the stage to Mara. So go ahead, guys.
PF guys here at Atlanta. In the SCR, there's two catalysts. Do they, one kind of cleans up the remainder of the ammonia. Do they have the same catalytic metal in them, or is it a different catalyst in each brick?
Actually, the bricks are all the same. It has, if I remember correctly, this OneBox has two separate rows of SCR catalysts, and each of those rows contains several different bricks. And what's actually interesting is that all of these bricks are exactly the same material. They are exactly the same coating.
Okay.
But the only difference is that on the two bricks that are closer to the outlet side, actually I can skip back to one of the previous slides. Right, so the two bricks on the outlet side have this the SCR ASC stripe. Right, so this is meant for cleaning up all the excess ammonia that is trying to escape the system. So basically, what we have is two separate rows of SCR, just as you can see here, doing the same thing on parallel.
Okay, cool. Thank you.
Right? Any more questions?
All right. So the first thing we're going to start off with today is the location of Dinex's SCR inlet temperature sensor. So Dinex has moved the inlet temperature sensor from the left side of the box where the OEM has it located over to the right side of the box. This is a design change because our flow of exhaust is going to be a little bit different than what the OEM's flow is going to be, which is outlined in the diagram. So where you see number 3, where the exhaust is flowing through our U-shaped mixing chamber, 4 is going to be the SCR inlet. Therefore, our temperature sensor is going to be located over on that side. I get some calls on this. I've never had an instance where someone wasn't able to get the sensor to fit over in that area. So this was done on purpose. No need to panic if you receive a Dinex OneBox and that sensor is in a different location. The next common question I get is air assisted versus non-air assisted. You still have to have an OEM part number to determine which Dinex OneBox you need. You can't determine which OneBox you need just based on that verbiage of air assisted versus non-air assisted. The 2010 emissions, to get the pressure they needed to move the DEF to the DEF doser, they used air supplied by the engine air compressor. Versus 2014 and 2017, they ended up accomplishing this electronically instead of using air. OneBox troubleshooting, I've heard various times that, well, this isn't an OEM part, so I can't use OEM troubleshooting. That is incorrect. It doesn't matter that this is not the OEM part. All of our specs are going to be matching the OEM specs. So if you get a code, absolutely use the OEM troubleshooting. There isn't any special, Dinex troubleshooting that has to be used. Anything the OEM outlines for the codes we're going to go over next is what you should use. So the common codes that I see quite often if I'm assisting someone in troubleshooting is our SCR NOx conversion efficiency is low, NOx outlet sensor drift low, and then high hydrocarbon absorption in the DPF. So we'll go one by one through these codes and, we're going to go through the steps and then some of the things that I've seen in the field. So our first one is your SCR NOx conversion efficiency low. This is the most common code and it has like 50 different potential causes. This reminds me also of like your general frequent regen code. that pops up on a Cummins engine where it's just one of 50 different things, and there's extensive troubleshooting that you have to go through prior to replacing your after treatment parts. Step number 1 is the most critical step. Do you have any other fault codes that are relating to the EGR system, fuel system, NOx sensors, anything air management system related, such as your turbo, intake air temperature, intake throttle valve, and intake manifold pressure? If you have any other fault codes in your system that are engine related, you're going to stop troubleshooting this code and you're going to perform troubleshooting for those other engine related codes. Now, if the above mentioned codes result in a repair, you're going to do that repair, then you're going to do a parked regen to see if your NOx conversion has come back up to where it needs to be. If your NOx conversion is now where it needs to be, then you're good to go. Just because you have a NOx conversion code doesn't mean your OneBox has failed. If you don't have any other engine related codes, keep in mind, it doesn't mean you don't have an upstream engine issue. It's that you maybe haven't met the criteria of what your ECM is looking for to trigger that code. So you have no other engine related codes, or say you do a repair and your NOx conversion is still low, then you're going to move on to the next step. You're going to check for temperature or pressure codes in the ACM, which is your after treatment control module. Troubleshoot those codes first. If you find an issue, perform your repair. Once again, you're going to do a parked regen and you're going to check your NOx efficiency at that point. So part of the calculations the truck is using to say, are we converting NOx efficiently, are the temperature readings and pressure readings. If you have a sensor that's not reading properly, that's where you could be converting NOx efficiently, but the computer thinks you're not because it's seeing a temperature that's out of spec or a pressure that's out of spec. If you find a sensor that's bad and you replace the sensor, your efficiency is good, then you're good to go. If you don't have any codes that relate to your temperature or pressure sensors on your OneBox, then you're going to move on to your next step. You're going to test for DEF or you're going to test your DEF fluid for oil or fuel contamination. There's test strips that you're going to use to test the DEF for contamination. Everyone should have these test strips on hand at all times. Anytime you have a problem with your SCR or with NOx conversion, you're going to want to check for contaminants in your DEF. You also want to check your urea percentage. It should be 32.5% urea. If you're not within spec, you're going to want to change out your DEF fluid, flush the system, get fresh DEF fluid in there. And then once again, you find that condition where there's contamination or improper urea percentage, then you're going to want to do that regen, see if your NOx efficiency is back to where it needs to be. The next step is to inspect the area where the DEF doser mounts. You're going to be looking for DEF crystallization. Now, if you have DEF buildup just right where the DEF doser mounts, that doesn't mean that your DEF doser has failed. It means you need to replace the gasket. So if you find this condition, replace the gasket, reinstall the DEF doser, and then you're going to, once again, run your regen to check for NOx efficiency. Then you're going to perform a DEF quantity test. So if you don't have leaking DEF buildup at the DEF doser where it mounts, you remove that DEF doser and you're going to put it into a cylinder and do a DEF quantity test and measure how much DEF is coming out of the DEF doser. If the DEF doser is leaking, then you're going to put a new DEF doser on, perform a regen to verify the repair. You also want to inspect for DEF buildup inside the SCR mixing chamber using a scope. So Karlis touched base on our DEF awning where the OEM says, hey, if you have buildup, put this awning on. Ours just come with the awning automatically as a prevention for DEF buildup. So if you do have DEF buildup, either your DEF doser was leaking or you have those high duty cycles, And with the Dinex OneBox, that will be prevented in the future. Now you have to keep in mind that some DEF buildup is acceptable. The OEM within the troubleshooting for this code, there are photo examples of this is an acceptable amount of DEF versus this is too much. So if you have some DEF buildup, it's not cause for concern. So another way you can look for DEF buildup in the SCR mixing chamber is during a parked regen. So if you graph a parked regen and you graph the NOx efficiency and your NOx sensors, if you have poor NOx efficiency at the beginning, and then once your NOx sensors start reading, because they have to be at a certain temperature before they'll register, if there's an SCR outlet NOx sensor spike at the beginning of that log, that's an indication that you have DEF buildup in the mixing chamber. Another indication would be if your NOx efficiency is going well, and then your NOx efficiency drops, and at the same time that your NOx efficiency drops, your outlet NOx sensor spikes. That means that everything got really hot and it was hot enough to burn off that excessive DEF buildup in your system. So if you've gone through all those steps, you've not found a failure, you're going to remove the DEF doser electrical connector and perform a low temp ATD. You're going to let this run for 20 minutes. So this is similar to a regen, but you're not going to be it's not going to be dosing DEF during this process. So this is where it's going to check your NOx sensors. So if you're running the simulated regen and you don't have any DEF dosing into the system, your NOx sensors should read within 50 parts per million of each other. OEM troubleshooting states that after you run this test, and if your NOx sensors are not within 50 parts per million, then you're supposed to replace the outlet NOx sensor and repeat the test. If they're after that, if they're still not within 50 parts per million of each other, then you're going to replace the inlet NOx sensor and rerun the test. I always say, and I believe Karlis has touched base on this on some of his NOx sensor training. If you haven't yet watched any of Karlis's NOx sensor training, make sure you check that out. We have them recorded and posted on our website. And we also have some on YouTube. We call them Dr. NOx. So NOx sensors can degrade over time. So if you have a truck with 500,000 miles on it and it's never had NOx sensors replaced, you run this low temp ATD and you're like, oh, my NOx sensors are not within 50 parts per million. I need to replace the outlet. At that point, I would just replace both the inlet and the outlet, because of NOx sensor degradation. You would want to have both new sensors so that they're both reading this, at the same levels of each other. I compare this to replacing fuel injectors. You got a truck with over 500,000 miles on it. You have one fuel injector fail. You're generally not just replacing one injector, you're doing a set. So if you get to this point, maybe you've replaced some NOx sensors, you've done a few other repairs, you're going to then run or clear the codes. You're going to have a code that trips when you disconnect your DEF doser. So you're going to reconnect that, clear your codes, perform a regen. If your NOx efficiency is above 85%, then you're good to go. If not, you're going to monitor the last 7 minutes of the regen, and that's going to be looking at your temperatures. So monitor the last 7 minutes. If you ask yourself, is the SCR inlet temperature lower than the SCR outlet temperature? If it's not, replace the OneBox. If it is, you need to check the difference between the two. And if the difference between your two temperature sensors exceeds 68.4 degrees, then you're supposed to replace the OneBox. At any point throughout this troubleshooting, if you're replacing the OneBox and you have not yet identified an upstream failure, or even if you have, you're going to want to go through your after treatment failure guide. The OEM used to have an upstream failure checklist, and a lot of people are in the habit of just like printing that off and saying, oh, I'm just going to go through this checklist. They have since updated that checklist to a whole entire guide that you follow different failure checklists depending on certain conditions you have. So you're going to review then the data from the low temp ATD and check for a drifted temperature sensor. If the SCR inlet and outlet sensors were within 45 degrees of each other after 25 minutes, then the OneBox has experienced an internal structural failure, and the upstream failure checklist does not have to be performed. If they're not within 45 degrees of each other, then you replace the drifted sensor. I'm normally not one to condone throwing parts at a truck ever, but if at any point you're questioning, do I need a OneBox? These are very expensive. It's a very expensive part. Even when you're getting, you know, an OEM quality part at an after treatment price, it's still an investment. And if you're questioning if you have a temperature sensor that's not reading properly, install a new sensor and rerun your testing. These sensors are really inexpensive, and you may have issues when you're removing the sensor anyways when you go to put a new OneBox on. So if there's a question, put new sensors on and rerun your testing. The next code we're going to go over is NOx outlet sensor drift low. Once again, and this really is for any after treatment related fault, you're going to troubleshoot any other fault codes first. Any other codes in that relate to your engine, troubleshoot that first. You're going to check for exhaust leaks or damage to your after treatment system. And then you're going to disconnect the def doser and perform a low temp ATD. The OEM states if the inlet and outlet NOx sensors are within 50 parts per million of each other, then you're going to replace the OneBox. If not, replace the outlet NOx sensor. I say before condemning a OneBox, after such few steps, you're going to maybe want to go in and do those troubleshooting steps that I outlined in your NOx conversion efficiency, because you may have some other issue going on. I've seen occurrences of DOC face plugging that's caused this code. So keep in mind, just because you don't have a DOC face plugging code doesn't mean you don't need to check for that. And then make sure you perform your upstream failure checklist. So now we have our high hydrocarbon in the DPF. The only reason this code sets is because of excessive idle, low engine load, and low engine temperatures. There's an updated ACM software level. So if you have this code, check Detroit servers to make sure your ACM is updated to the most current level, and update the software if necessary. I've never seen this code alone. It's always with another code. And if you have this code, stop idling. Our upstream failure checklist, touch base on that. It's no longer just a checklist, it's this whole guide. You're going to ask questions. Did you have any other fault codes of interest? Have the DPFs been maintained properly? Is the duty cycle optimal or less than optimal? There's a whole spreadsheet that they have to say, look at all this data and see where your duty cycle, your idle time is at. And then was there a recent upstream failure that was repaired? So if 2 months ago, a turbocharger failed, fuel injectors failed, you had a leak in EGR cooler, it could sometimes take a few weeks, a few months. I've seen it even up to 6 months down the road of an upstream failure. It could take that long for any contaminants that had entered your after treatment system to actually degrade those catalysts, whether it's the DOC or SCR, to a point where you experience an after treatment failure. So you don't want to go chasing your tail of saying, I know I have an upstream failure, I have to find it. You're still going to do your upstream failure checklist, but be mindful of, if I just experienced an upstream failure a few months ago, maybe that's what caused the problem. And for shops that it's like, if you're a fleet shop, you know your repair history. But if you're a drive-in shop, that's where you do have to go to the owner of the truck and say, hey, I need your maintenance records. I need copies of repair orders, even going back the last year so you can assess the history of that engine and what repairs have been performed. But I just really can't stress enough that if you do not locate your upstream failure, it's not a question of whether or not a replacement OneBox is going to, fail again. You are going to experience another failure. So make sure you find your upstream issue prior to putting a replacement OneBox on.
Good morning. I got a quick question. I'm from Traction in Montreal, Quebec. I've been told that for looking for parts into the system, we just can punch the VIN number of the unit to be able to look for whatever we need. Is that something that is possible?
That's a great question. We do have some VIN numbers captured. I think mainly EPA10, but we don't have 100% of VIN numbers captured. So if you put a complete VIN into our website and it says, sorry, we don't have anything for that VIN, that just means we don't have that VIN number captured. And you'd have to still get an OEM part number then to cross-reference. We will send out some contact information, at some point next week to say, hey, you need a OneBox looked up. This is who you can contact with your VIN number, and we can get that part number for you.
Perfect. Thank you.
You're welcome. Any other questions?
Hey, Mara, the James DPF guys here. So one of the things, especially in the 2014, 15, 16 Freightliners, was a fuel mapping issue that appeared to overtemp the SCRs. Is there, in the diagnostics tool, is there anything that would show you like max temp of the SCR at any point in history?
I believe, I know there's a log that you can go in and print out that'll show historical data. I know I've been sent those logs from customers before where I've helped with troubleshooting. So I can go through some of those that I have and look to see, does it have that data in there? I'm not 100% sure, but I'll look and follow up. And I can, when we send out communications to everyone, thanking you for joining, I can include that data in there of like, yes, it is, or no, it isn't. Because I know on Cummins Insight, it's really, really easy to just say, you go into your ECM image and say, I want to see the temperatures of your last 10 regions. I'm not 100% sure. I think there might be, but I will follow up and let you know.
Because I know I've seen, on other stuff and other diagnostics, I'm not sure what engine it was on, but it would say, max speed, max RPM, all these things are like, and I didn't know whether if there was a temperature recorded as well, because that would be very helpful if someone's having a OneBox failure to say, check this. If it's ever been above X, like 1200 degrees, 1300 degrees, then you likely have a SCR issue. I just didn't know where to find it and which diagnostics tools had it. So that would be helpful. Thank you.
Yeah, I'll look into it and let you know.
Are we able to access this PowerPoint after this meeting?
Yeah, I'm going to convert it over to a PDF format so it's easier if anyone wants to print it off. Still use your OEM troubleshooting. Some of, the code troubleshooting, I looked up a GHG 14. So you're going to have EPA10, 17. A lot of the after treatment troubleshooting is the same or very, very, very similar. So you would still want to access the OEM troubleshooting for the codes, but I'll get a PDF copy of this PowerPoint to everyone that's attended, so you can use it as a reference.
Thank you.
I went through everything pretty quickly. Karlis told me I could only talk for 20 minutes.
And then again from Traction, just a quick question. So basically, till what year you are able to supply some replacement? Because I'm seeing in the booklet you're about 2014 and 15. So the newer truck, you won't have it.
We have a OneBox that we've released for EPA 17, but I will ask for patience from everybody. These OneBoxes have like 192 components, I think it takes to weld, and it's a lengthy process to build them. We did do pre-sale requests when we released the EPA 17 OneBox and built up our inventory based on the pre-sales, but we've had a really, really high demand for those since we've released them. So we may come into some back orders with the EPA 17s. We also don't have every single OneBox part number captured. There are some out there. The ones where the outlet pipe come out of the side of the OneBox, where instead of the outlet pipe facing the same direction as that inlet pipe, if the outlet pipe comes out of the side of the OneBox, we don't have any of those offerings at this time. But we do have EPA 10, 14, and 17 options right now.
Perfect. Thank you.
You're welcome. And we do have both loaded, we call them loaded and unloaded. Loaded isn't with all the sensors and everything. It just means it comes loaded with DPFs. So that's something to keep in mind. If you're replacing a OneBox and the DPFs have also been compromised, you can purchase a Dinex OneBox that has the DPFs already installed into it for you, which is going to save you a fair amount of labor.